Welcome back, ladies and gentlemen. This is your 10.1b notes, second half of section 10.1. And in the first half, we talked about what was a radical function. Now we're going to really look at this vertex form of a radical function and how we can make transformations using it. Now, why do I put it in quotation marks? Well, because it's not technically a vertex. Vertex needs to be a minimum or a maximum. And this is neither of those things, this point right here, but it's still represented by the h and the k. And so because of that, we're going to use it. Now, one other thing to kind of keep in mind, and you don't necessarily need to write this down, but if I also were to graph y equals a times x minus h, excuse me, the square root of x minus h plus k, but then I make a negative, notice what happens now. What can we call that shape? Yeah, that's a sideways parabola, okay? And with it being a sideways parabola, this would be the vertex if it was facing the right way, up or down. But again, it's not. But it still works very similar to a vertex. And so that's why I call it vertex form. Is it correct? Who cares? It's close enough and it works for what we're trying to do. So, vertex form. Now, because it works the same way, then we can do our transformations in the exact same way. So I want you to think back to section 9.3, and in fact, now is actually a really good time to pause the video, go to your folder, and grab those 9.3 notes, because you'll see this is exactly the same thing. I'll even take a quick minute for you to do that. Sweet. If you look, the first transformation we made with the parabola was we adjusted k. And if we look here at our graph for the square root function, or the radical function, as k increases and it's positive, look what my graph does. It shifts upward. Same thing if I move it down, right? K is negative, it shifts down from the origin. So I like to call it vertex because it works the same way. I get a vertical shift up or down of whatever k is. If k is 2 or 3, it moves up 3. If k is negative 5, it moves down 5. Okay, so whatever k is, that determines my vertical shift. Same way that it did with parabolas. And you can guess, if h gets positive, it moves to the right. If h gets negative, it moves to the left. So if you're looking at those 9.3 notes again, you'll see it's the exact same story. H gives me my horizontal shift, left to right, of h. One more reason I like this is it's also going to still have that same quirky opposite thing. So if I see x minus h, that means h is positive, so it moves right. If I see x plus h, that means h is negative, and it moves left. And generally speaking, I still hate that about math, but also, just like I said in the notes there, it does still work. It is still true. If h is positive, I'll be subtracting x minus 4.5, and it will move 4.5 over. And if h is negative, and I move it 1.7 to the left, that would be x plus 1.7, and it would move 1.7 units to the left. So just the same as it worked with quadratics, this is still going to work with radical functions. So that's the good news. It's nothing new. And, excuse me, if k and h haven't changed, guess what? A still works the same as well, but it is a little different. Okay, I know. It's always a little different with me. I always say it's the same, and then I always make it a little different. I know. I apologize. But you'll see it's still similar, if not the same. All right, I'm going to zoom out a little bit so we can see this a little clearer. If A got bigger, so it was bigger than 1 in our previous chapter, chapter 9, we said that it was getting skinnier, and it was getting, yeah, we said it was getting skinnier. Well, now it's going to kind of work a little differently. We're going to use the word tall. Okay, so if A is bigger than 1, you'll notice the graph starts growing. All right, and what it's really doing is it's shooting up faster. All right, now it's shooting up to 20 and 40. Okay, it's shooting up faster. So I will say if A is greater than 1, the graph gets taller. That's the word I'll use. Is it still called a vertical stretch? Yes, it's still a vertical stretch. But now the word we would use is taller. But I will write vert stretch here in my notes as well. If A is between 0 and 1, that means if I get the fraction of the decimal again, then now the graph will get shorter. That would be the horizontal stretch. Okay, so look at that again now. If I drag this down here to less than 1, there's 1, and I drag it less than that, you'll see it gets skinnier and skinnier. I'll zoom in for this one so we can see it. Oops, there we go. So there's A equals 1, and as it gets closer and closer to 0, the line itself gets closer and closer to 0. Okay, so again, if A is greater than 1, the graph gets taller. If it's less than 1 but greater than 0, it's going to be shorter, closer to the origin, or the x-axis. And then, of course, what do you think happens when it goes negative? It flips down, just as it did in the previous chapter, right? So if A is negative, we call that a flexion over the x-axis. Okay, so again, in a way, this is something new. In a way, this is the same old news that we did last chapter. Okay, nothing really has changed. The only thing that's different is now we have the square root sign here instead of the squared sign at the end of it. Transformation wise, everything works the same. K moves it up or down, H moves it left and right, A stretches it, and also will flip it over the x-axis. Okay, that is the end of the notes for section 10.1. If you have questions, you can shoot me an email. You can post me a message in Schoology. And there's also that questions discussion board that you can also post to. And for this unit in particular, it might be very helpful if you guys all posted your questions to that discussion board, because you might be able to help each other out and answer your questions before you come to class. But any questions I receive, I won't respond individually, but I will bring them forward to the whole class, and we can talk about them once we get into class and actually start doing some of the practice with this. One of the benefits of doing it this way. So, if you have questions, let me know. Otherwise, looking forward to seeing you guys in class next time. Thanks for watching.